In Objective 3, we investigated parabolas that go up and down. In fact, I think in your class you spent 2 class periods studying these things because there was a lot of new stuff presented to you. Well, Objective 4 takes a lot of the same concepts, except the parabolas are now going to go either to the left or the right. And you can tell that by the equation. When x is the variable that goes to the first power and y is the variable that's being squared, that's when you know the parabola is either going to go to the left or to the right. It's what we call a sideways parabola. Now on this first one, this is the parent function x equals y squared. It hasn't been translated, so you know the vertex is right there at 0, 0. But because it's a positive y squared and the leading coefficient is 1, it's going to open to the right and it's going to have what I call a normal width to it. Relatively speaking, it's a normal width. Now, x equals negative y squared. Same thing, there's no translation to it, so the vertex is going to be right there at 0, 0. And it's going to open to the left because of the negative sign. So, there's our parent functions, opening left and right. Now, we don't need to spend as much time as we did with Objective 3 with these because everything means the same thing. X equals negative 1 over 20 y squared tells us a couple of things already. This parabola is going to open to the left. It hasn't been translated, so the vertex is going to be at 0, 0. But because that leading coefficient is such a small value, 1 over 20, it's going to be a relatively speaking wide parabola. I'm going to do my best to make a wide parabola. Now, we know the same two things happen. The focal point or the focus is always on the inside of the parabola, and the directrix is in back of the parabola. So the directrix is going to be right here. But both of those things are determined by that formula, C equals 1 over 4A. So that very same formula that meant so much back in Objective 3, it still means a lot in Objective 4. And the A value is negative 1 over 20. So C equals 1 over 4 times negative 1 over 20, because that's what the A value is. Now, if you take that to the next step, 4 times negative 1 is negative 4. So now we have 1 over negative 4 over 20. This can be reduced. 4 over 20 is 1 over 5. So now we have 1 over negative 1 over 5. And like we saw, we're not going to go through the math of why this happens again, but 1 over negative 1 over 5 is simply negative 5. Now, the negative in this simply means the parabola is opening to the left, so I would actually have to go to the left to find the focus. So if I took 5 units or 5 steps inside the parabola, I'd be right there. So there's the focus. So if I'm at 0, 0, and I go 5 steps to the left, I'm now at negative 5, 0. So I know that's my focus. Now I know that also shows me how many steps I need to go behind the parabola or in back of the parabola to find the directrix. 1, 2, 3, 4, 5. And there's my directrix. And it happens to be a vertical line. Well, I tried to make it a vertical line. And that equation would be x equals negative 5. Now, the only other thing I need to find are the focal chord endpoints. So if I went out here and hit the parabola, and I went out here and hit the parabola, what would those points be? Well, that's dependent on what 2c is. So if c is -5, 2c would be -10. Now, this is really just a distance, so if you want to forget about the negative in this number, you can. But so all it's saying is this: if I'm at -5, 0, to be at the to be at the focus. If I take 10 steps down from here, I'm now at -5, -10. And if I take 10 steps up from here, I'm at -5, +10. So those are my focal chord endpoints: -5, 10, and -5, -10. Now, one last relationship sometimes they want to know is, what's the focal chord length? Well, that's just the total distance of the entire focal chord. Now, if I went 10 steps down, because that's 2c, and I went 10 steps up because that's also 2c, then it's just 4 times c, which is 20. So I went 10 down, 10 up. So my focal chord length equals 20. Just like in Objective 3, some of the problems that you're asked to do on Objective 4 is write the equation of the parabola from given information. So, what if we knew the focus of the parabola was at 10, 0? So I've gone ahead and I've marked 10, 0 right here. And what if we knew the directrix of the parabola was x equals -10? So I've made that line x equals -10 right there. What would be the equation of the parabola? I'm going to do this in a little bit of a different way than I did Objective 3, because there's really 2 ways of doing it, and whichever one you like better, that's the one you can do. Now, since we know this is 10, 0, and we know this is x equals -10, right now we know the vertex of the parabola is right there in the middle at 0, 0, because we take 10 steps to get to the focus, and we take 10 steps the other way to get to the directrix. And the vertex is always in the middle of the focus and the directrix. So, the vertex is right there at 0, 0. And we also know the parabola opens to the right because the focal point, or the focus, is always on the inside of the parabola, in the opening of the parabola. So the parabola must look something like this. That's what the parabola looks like. Now, what we're going to do is we're going to use this relationship right here, knowing that c equals 10. The distance from the vertex to the focus is the same thing as the distance from the vertex to the directrix, so c equals 10. Now, we're also going to use the relationship that we know, c equals 1 over 4a. Well, if c equals 10, then that means I can substitute the c value for 10 right here. So 10 equals 1 over 4a. Now, if I do a little bit of math, I'm going to cross multiply 40a 10 times 4a is 40a. 40a equals 1. Now, to solve for a, I'm going to divide both sides by 40 because I want to get my a. A equals 1/40. And that's really all I need to know the leading coefficient of the parabola, because I know the vertex hasn't been translated. So the vertex is sitting there at 0, 0. So the parabola is going to have as its equation x equals 1/40 y squared. And that's the equation of this parabola. For this particular parabola, especially since it had its vertex right at 0, 0, this method was a whole lot faster than the method I showed you in Objective 3. But sometimes the method I showed you in Objective 3, where you had to use the distance formula, is actually faster than this one. You're going to come across examples of both. The last part of Objective 4 spirals us back to circles. Just so we don't forget what's going on, find the center and the radius of this circle. Now, first of all, how do we know it's a circle and not a parabola? Well, notice the x is squared and the y is squared. When both of the variables are squared, you know it's a circle. Now, neither one of them is presented as a perfect square, so we're going to have to complete the square for both the x and the y. So I'm going to do quite a few steps at once. I'm going to group my x's together. I'm going to make room for that third number that completes the square. I'm going to do the same thing to the y's, and I'm going to move the minus 15 to the other side. So it'd be x squared plus 6x plus the missing number. Now, it would be the same thing for the y's, plus y squared minus 10y plus the missing number equals. Now, I'm going to start off with that 15 only on the other side, so it would be a positive 15, but then I'm going to add the sum of those two missing numbers. So now we start the process of completing the square. For the x, take half the 6, which is the 3, and square it, and that makes 9. Do the same thing for the negative 10, which is the coefficient of the y. So take half of negative 10, which is negative 5, square it, and that makes 25. So what did I add to this side? 9 and 25, which makes 34. So the perfect square that I created with the x's would be x plus 3 quantity squared. Now for the y's, the perfect square I created was y minus 5 quantity squared equals, now 15 plus 34 is 49. So there's the equation of my circle, and from the equation I know the center is negative 3, positive 5. And I also know the radius is the square root of 49, which is 7.